So reducing radicals. That's another way of saying reducing or simplifying square roots. So first thing you want to check is that the radical you're reducing isn't a perfect square. You might recognize some of the smaller ones, but you can go ahead and plug them into your calculator if you don't recognize it and see if it gives you a decimal or not. If it gives you a decimal, then we need to reduce it or simplify it using one of these two methods. Now this first one here is probably the faster method by using perfect squares. It's recognizing that there's a perfect square that is a factor of this number. So actually, if you know your perfect square is up to 12, you could use your calculator and divide some of them out. I'm going to cut straight to the chase on this one. This is really the square root of 144 times 2, which can be broken into two radicals. The square root of 144 is 12, and the square root of 2 cannot be simplified any further, and there are no perfect squares that go into it. So there's our final answer. Now, if you didn't know that 144 went into that, you could use a smaller one, and then you would just have to repeat the process. So, for example, 288 is divisible by, let's try 16. So we might say, alright, this is really the square root of 16 times 18. So this is really this problem. So what I'm left with here is that I have 18 inside of that. Excuse me, I made a mistake there. This should really be jumped ahead of myself. And then 18 can be broken down into the square root of 9 times the square root of 2. So really we have 4 times 3 times the square root of 2, which gets us back to the first answer we got. So you get there eventually, it just might take a couple more steps. Then we have this prime factors method, which involves, you don't need to look for square roots, so it might take you a little bit longer, but it'll still work. So what my goal is, jumping ahead of myself again, I need to come up with all the factors of 72 that are prime numbers. So I just start off, I'm going to break this down. I know that this is 9 times 8, and 9 is 3 times 3, 8 is 4 times 2, and then this is 2 times 2. So all of these numbers can't be reduced any further into factors. So now I have one big radical sign, and I'm going to line up all of my prime factors underneath. And what I really see here when I line them up this way is that I have a number that was a factor of 72 that was 3 times 3. Now, 3 times, if I have a number in there that's itself times itself, that must mean that I can take the perfect square of it. Same thing with 2 times 2. This means that 9 was a factor of 72 and 4 was a factor of 72, which we learned in this method meant that we could factor them out. So the square root of this pair here will be 3. The square root of this pair here will be 2. And we're left with a 2 that we can't reduce any further. So in this case, our final answer is 6 root 2. So in this method over here, if you have a pair of numbers, you take one of them to the outside of the radical and cross them off from the inside. Take one to the outside, cross them off, left with 2 underneath.